Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. 2-chloromethyl furan undergoes SN1 solvolysis because the carbocation intermediate, furfuryl cation, formed after loss of Cl is stabilized by resonance with the furan ring oxygen. This delocalization spreads positive charge to multiple positions of the furan ring. Moving on to the next step. 2-chloromethyl furan loses Cl under SN1 conditions to form a resonance-stabilized furfuryl carbocation. The positive charge is delocalized not only on the benzylic type CH2 plus carbon but also onto C3 and C5 of the furan ring via the oxygen lone pairs. Moving on to the next step. The primary carbocation at the exocyclic CH2 plus position resonates to place positive charge at C5 and C3 of the furan ring through the oxygen. This gives three major resonance contributors with electrophilic character at the exocyclic carbon, at C3 and at C5 of the ring. And for the final step, methoxide from CH3 owner in CH3O attacks each electrophilic site. Attack at exocyclic CH2 plus gives to methoxymethyl furan product A. Attack at C5 of the ring carbocation gives a product where OCH3 is at C5 and CH3 or CH2 rearrangement gives the structure shown in B. Attack at C3 of the ring carbocation gives a product where OCH3 is at C3 and the CH3 group ends up at C2 giving structure C. Because the SN1 mechanism produces a delocalized carbocation with electrophilic sites at multiple positions, methoxide can attack any of these positions, yielding all three products A, B, and C. Options A, B, and C alone are each only partially correct because they account for only one of the possible attack sites on the delocalized cation. Since all three products are simultaneously possible, option D, all of these is the correct and complete answer. Therefore, the correct answer is D. Therefore, the correct answer is option D.